The ink in Urbain Le Verrier's ledger created a planet that did not exist. By the middle of the 19th century, Newton's law of gravity had become one of science's greatest triumphs. It had already guided astronomers to Neptune without anyone seeing the planet first. Mathematics pointed to an invisible world. Telescopes eventually found it, and confidence in the method became almost absolute. So when Le Verrier sat in the Paris Observatory, surrounded by pages of orbital calculations, he trusted the numbers more than his own doubts. One figure refused to disappear. Mercury's orbit drifted by a tiny amount, 43 arcseconds, every century beyond what Newton's equations predicted, after accounting for every known planet. The discrepancy sounded almost insignificant, yet it survived every calculation, remaining after correction followed correction. On Le Verrier's pages, columns of figures eliminated one possibility after another, until only a single explanation seemed to remain. Something unseen had to be orbiting closer to the sun. The proposed world received a name before anyone had truly seen it: Vulcan. A few months later, a country doctor named Edmond Lescarbault claimed that a dark object had crossed the face of the sun. His telescope was modest. His observatory was little more than a rural clinic. Even so, Le Verrier traveled to inspect the observation himself. He questioned Lescarbault relentlessly, examined his homemade equipment, compared timing records, and studied the charcoal marks that recorded the transit. When he left, he accepted the observation as genuine. The announcement spread quickly through the scientific world. Vulcan entered astronomical literature. Observatories prepared new searches. Maps of the solar system began making room for a planet that nobody could visit, photograph, or consistently observe, but whose existence appeared justified by the most successful mathematics of the age. The search had become official. Finding Vulcan, however, was never expected to be easy. Any planet so close to the sun would disappear into overwhelming daylight. Only during a total solar eclipse or an exceptionally rare passage across the sun's face could observers hope to catch it against a darkened sky. That limitation transformed every eclipse into an international expedition. Heavy brass telescopes crossed continents inside wooden crates. Temporary camps rose beneath eclipse paths stretching across Spain, North Africa, the American West, and remote islands. Observation sheets waited beside eyepieces, blank except for carefully drawn circles surrounding the eclipsed sun. Every expedition expected confirmation. Most returned with uncertainty. Some observers reported nothing at all. Others believed they had found Vulcan. Their reports rarely agreed with one another. The tension sharpened after the eclipse of 1878. In Rawlins, Wyoming, respected astronomer James Craig Watson watched totality unfold through powerful instruments, while fierce mountain winds shook the temporary camp. Nearby, inventor Thomas Edison tested an experimental device designed to measure heat from the solar corona. The eclipse camp had drawn together some of the era's most accomplished observers. Watson emerged convinced he had located not one, but two intramercurial objects near the black disk of the sun. Almost at the same time, Lewis Swift reported another sighting from Colorado. For a brief period, Vulcan seemed alive again. Astronomy, however, does not end with a single observation. Christian Peters later compared the reported positions. The coordinates fail to match each other. They also fail to describe any stable orbit around the Sun. Mechanical distortion from heated telescope mounts, combined with the frantic pace of totality, offered a far more ordinary explanation. The observers had almost certainly mistaken familiar stars for an extraordinary discovery. Their notebooks survived. The planet remained out of reach. Decades passed. Observation sheets kept returning from eclipses filled with conflicting sketches, hurried corrections, and empty spaces where certainty was supposed to appear. Eventually, human eyesight itself came under suspicion. At California's Lick Observatory, astronomers replaced fleeting visual impressions with something less vulnerable to expectation. Engineers built a specialized 4-camera system dedicated entirely to photographing the region surrounding the eclipsed Sun. Instead of relying on memory during 2 brief minutes of darkness, chemical glass plates would preserve everything. The photographs reached farther than the human eye. Thousands of faint stars appeared. Vulcan never did. Inside temporary darkrooms in Sumatra, Spain, and the Pacific, photographic plates emerged slowly from chemical baths. Astronomers lifted the dripping glass toward oil lamps. Tiny black points filled the images exactly where distant stars belonged. The predicted orbital path remained empty. That absence created a larger problem than any claimed sighting. Mercury's orbit still refused to match Newton's calculations. The missing 43 arcseconds had not disappeared simply because the planet had... The search had removed one explanation. It had not removed the anomaly. Then another stack of handwritten pages appeared. In Berlin, during the autumn of 1915, Albert Einstein applied a radically different description of gravity to Mercury's orbit. Instead of treating gravity as an invisible force acting across perfectly flat space, his equations described mass bending space and time themselves. The calculation followed naturally. Mercury's unexplained motion no longer required another planet. The missing 43 arcseconds emerged directly from the geometry surrounding the Sun. Nothing needed to orbit inside Mercury anymore. Einstein later admitted that the result affected him so deeply he struggled to work for days after realizing the calculation matched observation. The planet had never been hiding. The explanation had... A few years later, eclipse expeditions once again pointed telescopes toward the darkened Sun. This time they were no longer searching for Vulcan. They were measuring the bending of starlight predicted by General Relativity. When those observations were announced in London, confidence shifted away from the invisible planet that generations had pursued and toward an entirely different understanding of gravity. The eclipse remained. Its purpose had changed. Today, the observation sheets, telescope sketches, photographic plates, and mathematical ledgers still survive in observatory archives. They preserve the record of decades spent searching with extraordinary care for a world that never occupied the sky, while a persistent remainder of 43 arcseconds waited beside them until the equations themselves finally changed.